Hi, so welcome to the another session of Internet of Things. So in this class, we will study about the IoT and the 5G. That's the Internet of Things and the fifth generation of technology. Now, as we know that IoT is Internet of Things, your anytime, anywhere, and anything. That means at any place, the devices are connected to any time. Now, the fifth generation of cellular technology. Now, as we know that a large number of devices here will be connected to internet. So that means they require a new service model and they require new capabilities so that they are interconnected to each other and exchanging that information here. So fifth generation of this technology, we can simply say the 5G, that is supposed to act here as a key driver or key support for your Internet of Things. So basically, the current research, which is basically going on, your fifth generation of cellular technology, that is also geared here. That what is basically to expect from this technology and how it can support your Internet of Things. So that means this basically to act as and support for your Internet of Things. Now we know that certain sensors and actuators, they don't need gateways to get connected to the backbone network. They can directly be connected to your GSM systems, your LTE, or your now fifth generation of technology. So it has, that means this system is supposed to act as the backbone for your fifth generation, for your Internet of Things here. So now there are many technologies which will be here standardized for your fifth generation of technology, and that will have a direct impact on your Internet of Things. It means those technology are then used by your IoT devices since it is acting as a backbone for your Internet of everything here. So now for the upgradation of your fifth generation of cellular technology, the basic new things which are introduced and which will be here greatly used in your Internet of Things, and it will enhance that connectivity level here for the various smart devices around us. So first of all, like we have the millimeter wave communication, then cognitive radios, and support for IoT. So we will study each of these one after another. Now, first of all, we have the millimeter wave communication. So this millimeter wave communication is supposed to be here in your fifth generation of cellular technology. So this MWC is basically, or we can say that this technology is here going to improve the wireless internet access. Now we have been using another technologies also. Now if we have to see that what, if we have to see the glimpse that what impact it will make here for the future wireless internet access, so we should know just that what are the present techniques which we are using now at present for your high data rates. What we're using is like your mobile WiMax, and we are using your 4G systems or your long-term evolution, that is your advanced version. Now, this is your IEEE standard here, which is able to provide you speeds like up to, in very good atmosphere, up to 128 Mbps for your download and like up to 50 Mbps for your upload. Now, after that, we have the fourth generation of cellular systems, your LTE systems. Now, these are able to provide speeds ranging from like 100 Mbps and 1 Gbps here for your downstream. So your fourth generation of cellular technology is able to achieve these high data rates with the utilizing your higher frequencies and your MIMO technology. So it is here using high frequencies and MIMO technology, which is your multiple input and multiple output technology, to increase the strength of the signal here. Now, yes, these high frequencies and this multiple antenna technologies will be used in the fifth generation of cellular systems also. So that's here we have the multimeter wave communications, which basically allows the wireless internet access to use the millimeter wave bands in your frequency, like ranging from 20 to 60 gigahertz. So we can say that here the fifth generation of your cellular technologies will be using these frequency ranges here. Now note out high throughput will be an essential outcome of a generation of cellular technologies, but it is here also to support a large number of smart devices, because what's happening with the internet of things, like in the previous scenario, if we had like a number of smartphones, but now it is changing here to like 10 to 100 times smart devices here. Now, this technology here will allow this fifth generation of wireless internet access to access this millimeter bands of frequency in this range here. Now, this comes here with the certain limitations also. Now, if we have the frequency ranges greater than 30 gigahertz, so that this kind of frequency range is basically here absorbed by the certain chemicals, or we can say the absorptions in the atmosphere. So there has to be a remedy for that, so that the signal strength doesn't fall. So for that, the fifth generation here will be using smart antenna systems. Now we're using MIMO technology here in your fourth generation. So your fifth generation is using the massive MIMO technology. That means an area of antennas is used here for high beam forming. So if your fifth generation of cellular technology is using such kind of technology, and this is acting as in support for IoT, so at the end we can say that yes, this backbone, if it's acting as a backbone for IoT, so it is providing enhanced services for your smart devices which are connected to each other in an environment. So this millimeter wave communication was the first standardized upgradation for the fifth generation of cellular system. After MWC, the next thing which we're going to study here is your cognitive radios. Next, we have the this cognitive radios, we can say that the smart radio system. Now, the fifth generation of system of cellular technology here can become more smarter by utilizing these cognitive radios, or we can say that the smart radio systems. Smart radio. So this is basically implemented here. We have SDR, which is your software defined radio. Now this is considered here as a smart radio system because it is here able, or we can say that this smart radio system here can be programmed and configured dynamically with the help of your softwares. So that means here we can choose the channels. That means this smart radio system here is able to choose the channels. Now the channels are here selected on the basis of availability. Now once a channel is selected here, after that these radios here can modify the connection parameters to increase the signal strength here. So this is how these technologies are making the fifth generation as in more smart systems, and ultimately we are getting the benefits of fifth generation of cellular technology for our Internet of Things here. So now here you talk about it, the IoT and the 5G. We can say that the support of 5G for your IoT. Third, we have the support for Internet of Things. Now we know that this fifth generation of technologies 5G will be commercialized by 2020, and the smart devices, the number of smart devices is also going to be a number of billion devices here. So when this fifth generation is implemented by your 2020, so there will be a huge coverage demand for your smart devices here. So we have always been saying that it is providing the high through very high data rates, like to your 10 Gbps here. But this fifth generation, this 5G, just is not supposed to be only a high-speed internet connections, but it is supposed to be here and connectivity backbone for your smart interconnected world. So we can say that the fifth generation of wireless communication is a new roadmap of an interconnected world where a billion of devices are exchanging their information here. So that's why it's acting here as a backbone, a key driver for your Internet of Things here. So just not your cognitive radios, or just not your massive MIMO technologies or your millimeter wave communications. There are certain enriched features developed for your IoT that will work here with your 5G. Now, like another key enriched features include like your MIH, which is your media independent handovers. So as we know that handovers are supposed to provide the seamless connectivity. Now here we have media independent handovers for your IoTs and your 5G, because there will be a number of devices from different kind of environments and they will be having different access points. So if one device is changing its access point, so that means the data should be transferred from one access point to another, or we can say that the data is being transferred from a private network to a public network, so that data should be here transferred without any loss. So that's why we have here media independent handover. So because there are certain layers in our wireless interfaces, like we have the network layer, the data link layer. So that means when data is being transferred here from one layer to another layer, that should be transferred here without any loss. Now, for example, if there is some information being transmitted from a private environment, from a automated vehicle, now if that has to be transferred to some public interface, so that is here transferred with the help of your MIH without any loss of the information. So another use cases of your Internet of Things with 5G can be like your automated vehicles. Now, we know that these automated vehicles here will be embedded with your sensors. Now, we say that it is using here SDR, your software defined radios, your smart radio system. So, these sensors with your 5G as a support, so these will be here able to select, or we can say that, and scan the best frequencies which are available for transfer. So that means we have here a degree of freedom that we can choose the radio channel here, whatever we want, or we can say that the system here will select the best frequencies here with the help of your SDRs, which basically uses your spectrum scanning and selecting those frequencies here. So that means when it is using this technology, it will be able to communicate this information to internet here or to cloud analytics, so that information is processed correctly over there. Now, this 5G here can be a support for your IoT with the help of your wearables also. As your Internet of Things is being embedded here into every kind of device around us. Now, for example, if someone is going to for a grocery shopping, so while doing the grocery shopping, someone can monitor their vitals also, because we have technologies like MIH. It will be making, we can say that the transition from one network to another. That means transitioning or transferring the information here from one network to another. So you are doing here one thing, but it's keeping you update with the another things which you require. That means you can know here that it will be transferring the information from another network, that this is the thing which you need to buy at this time here. So whatever the technologies we are here using for Internet of Things, they will be supported here by the fifth generation of technology. So that's why we're seeing here that this 5G, the fifth generation of cellular technology, is just changing the era of the interconnected world where a billion of devices are exchanging the information here. Now, if we just look at the 5G design goals and how it is going to benefit the this system here, the Internet of Things systems. Now, for example, we just consider here your IoT, then your existing 4G systems, and then your fifth generation of cellular system. Now, like first of all, we talk here about the data rate. Now, for your IoT, this could be very low because we know that the Internet of Things here, the basic requirements are your low throughput, low power, and low bandwidth here. And for your 4G, it could be 100 Mbps. For your fifth generation, it's 1 to 10 Gbps. Another key factor with how it latency. For your Internet of Things, from 2 milliseconds to 2 hours. Now, for 4G devices, this latency rate is moderate, but for your fifth generation of cellular technology, very low latency rate, only 2 milliseconds. Next, we always talk about energy efficiency here, so battery life. For IoT, up to 10 years. We have for 4G the smartphones, and we know how that works here. But for 5G, it here depends upon application. Now, what application it is supporting here for this platform, it depends directly on the application here. Now, after that, the multiple access. Now, IoT here is supporting massive devices. For 4G, the multiple access is like you have on the basis of also different smartphones, mainly for your smartphones. And here you have the devices. Now, here you have bursty. So that is how it will support your IoT, because here sometimes you only need to send small packets of data, not only consistent flow of data. Now after that, another parameter here, the network support. Now IoT is basically an overlay network. That means it is here built on another networks. Now 4G and 5G, these are basically your head nets. That's your heterogeneous networks here. So these are here. That means this is here supposed to act as key driver for your Internet of Things here, because the demands here is like number of devices. This is low. Now we know that this technology is here going to be a high speed technology, but here demands are less, so it can meet here the data demands for your Internet of Things here. So that means with fifth generation of your cellular system, we are heading towards world of Internet of Things. That means evolution of complete IoT. Now, with time, your platforms have been changing. First of all, you have initially these featured phones, then trending towards smartphones, and now you have the popular trend of IoT, which has fifth generation of cellular systems, access virtualization, wearable devices, and portables also. So that's an evolution towards a world of IoT. So this is in this class we just studied that how the various emerging technologies which will be used in your fifth generation of technology, how that will benefit for your Internet of Things, and how 5G can act as a massive support for your Internet of Things. So this is all here for today's session for your IoT. We will continue with the next topics in our upcoming sessions. Thank you so much.